or as our inputs get smaller? Okay. All right. So good questions. This was helping us think about, so we've been looking at functions for a while. We haven't looked at a whole lot of tables. So thinking about tables can help us understand what is going on and ask questions about where we're going here with our functions. Eddie, good morning. Thanks for joining us today. I'm going to give you a link here to the PearDeck in the chat. Okay, today we are going to be still talking about function notation that we've been doing for a while here. And we're really going to be focusing on describing the rules of the function as they relate to the function notation. Who can remind me what we've been talking about as far as a rule of a function? Where does that rule come into play? Who remembers? So think back to our function machine. Where does that rule come into play in our function machine? Ryan, where's that rule come into play in our function machine? You don't know? Okay, so Juan's saying, yeah, our rule is going to tell us that we are going to have an output. That rule that gives us that output is also going to be that work that we do inside of our function machine, right? We put our input in, we do some work based on that rule, and we get an output out. All right, good. Okay, our goals for today. By the end of today, there are two things we want to be able to do. First of all, we want to understand rules of functions when they're written in function notation. We've been talking about rules. We've been talking about that work that we do. Today, we're going to talk specifically about how do we make that work make sense when it's written in function notation. And secondly, we want to be able to describe in writing what the rule of a function means for a given situation. All right. Who has questions on either of these goals today? No questions? All right. Let's see. Okay, let's do a little review of our vocabulary. So we were talking about function notation. And we said that function notation is a way of writing the output of a function that we've given a name to. So in this function here, we've got a function that says f of x equals x plus 5. Who can tell me what the name of this function is? It's f. Yeah, f is the name of our function. Okay? And what is the input of our function here? Jesus, what is the input of our function? Jesus, do you know? How about Jose? What's the input of this function we have right here, the f of x equals x plus 5?
Is the input fx or f(a)(5)?
It is right. It's the f of x is the input part. The f is the name, and that x is the value that we're going to put in there. Right, exactly. Okay, and then x plus 5 represents what? Who knows what that x plus 5 is? Brian, what does x plus 5 do? It's what? That's right. That's what's going to give us the output. That's the rule that we do, that work that we do inside our function machine to get our output. Okay, we've been using this picture of a vending machine to help us understand these functions for a while. So thinking about these inputs and outputs as far as this example goes, this is like saying our input of our function is going to be the A5 button. And the output of our function is going to be a bag of Doritos. So as in function notation, somebody describe to me, what does this mean? F of A5 equals Doritos. What does that mean as far as our function goes? Juan, what does that mean? What does it mean as far as if I say F of A5 button equals Doritos? What does that mean as far as my function? All right, who can help Juan out here? What does this mean? Brian, you're the Dorito lover in the class. What does this mean? Yeah, okay, yeah. So Brian's saying, if I push the A5 button, I'm going to get some chips. Exactly. Like the A5 is the input that I'm going to push that input button on my vending machine. And I know that that A5 button is going to relate to exactly one place in that vending machine that's going to give me that output. And Brian knows that every time he goes to that vending machine and pushes the A5 button, he's always going to get Doritos. He's never going to get Starburst. Okay? So these are the kind of descriptions we want to be thinking about today, thinking about these rules as they relate to function notation. We want to be thinking about what is our input and what does that input do in order to give us our output. Okay, let's look at another situation here. This situation says that a machine in a laboratory is set to steadily increase the temperature inside. Okay? The temperature is in degrees Celsius inside the machine after being turned on is a function of time in seconds given by this equation here. Okay, what are some of the important things that we know given this description right here? What are some of the key things that we know about this machine? What's an important thing? Okay, it's telling us about temperature. All right, so we know that we're talking about temperature. And temperature is a function of time in the seconds. Let me switch over to our whiteboard here. Okay, temperature is a function of time in seconds. And we know that time, it looks like our time here is given by the variable t. Okay, so we've got this function here. How would you read this function? Jose, can you read this function for me? What does this function say right here?
Which function? Oh, the one.
The equation there in the middle. Like, how would you read that function?
Time in seconds.
Okay, the first part's telling us the time in seconds, right? You got that part perfect. Now, what about this part over here? What does this part tell us?
Is it the increase of the temperature?
Okay, it's going to be, that's what's going to give us the temperature. Who else can help out? How would you read this second part of the equation? Brian, how would you read this part of this equation? The temperature is going to be what? 22 plus what? Okay, 22 plus the time times this other thing we've got right here, this 1.3. Okay, so we're going to say that this function, so f of t, or a function as it relates to the time, is going to, as the time is going to be 22 plus 1.3 times seconds. And Max just told us what we're thinking about here. Max, remind us again, what are we thinking about here as far as the time, and then what are we thinking about? The temperature. Okay, so the output is going to give us the temperature. Okay, so now we know what's going on in this function. We've got a function that relates to this machine. It's going to be turned on for some amount of time. The temperature is going to go up, and we're going to get a temperature based on this rule that is 22 plus 1.3 T. So this is our rule right here. Okay, so our first question here in the PearDeck is, what does f of 3 mean in this situation? Okay, and I've got a sentence stem here to help us out. So f of 3 means when the something is 3, the something else is something. Okay, so if we know it's f of 3, what does this mean? When what is 3? When the seconds is 3, thanks one. When the seconds is 3, so after 3 seconds, that might be a more grammatically correct way to say it. But when the seconds when we've gone past 3 seconds, then what? What are we going to measure after 3 seconds? I'm letting one finish typing here. Okay, so after the seconds, the temperature, okay, is going to be what? How are we going to figure out what the temperature is going to be after 3 seconds? Jesus, what do we have to do to figure out the temperature? How do we evaluate this function for an input of 3? Anybody help Jesus out here? Max, did you have an idea? No? Okay, so remember, oh, wait, I'm seeing Juan typing. Gonna give him a second here. Okay, just plug in the 3 and solve it from there. Easy as that, right? Okay, so we're gonna take this t, we're gonna kick the t out, and we're gonna put our v in its place. Put our 3 in its place. Hey, Max, why don't you step in the hall? Okay. That's okay. You need to step in the hall. Okay. If you need to step in the hall, okay. Okay. So we're going to kick the t out of the function, and we're going to put the 3 in its place. So we're going to get an expression that's going to look like 22 plus 1.3 times 3. Okay, now we just have to do that math. We can do that in our heads. If we can do that math in our heads, we can work it out on a piece of paper. We can pull up a calculator and do that math. Let's see if we can do this in our heads. If we're going to do 1.3 times 3, how can we break that down and make that easy to do in our heads? I might break this down into like 1 times 3 plus 0.3 times 3. All those dots there are a little bit hard to tell. So 1 times 3, Brian, what's 1 times 3? 3. What's 0.3 times 3? Do you guys know how to do 0.3 times 3? What's 3 times 3? 9. Okay, when we have a decimal here, we just have to put that point in its place. So 1 times 3 is going to give us 3. 0.3 times 3 is going to give us 0.9. So we get 3.9. We could check that out with a calculator if we wanted to double check ourselves. And then we're going to add that to 22. 22 plus 3, 22, 23, 24, 25 will give us 25.9. Okay. When the seconds is 3, after 3 seconds have passed, the temperature is 25.9 degrees. Okay, we got it. We even figured out the exact value of that. All right, let's look at this other one and see if we can figure out what this one is. There's another sentence stem here with some blanks in it. Now we want to know when the blank is blank, the blank is blank. Okay, so what do we know here? Are we still going to have seconds and temperature be our inputs and our outputs? Is seconds still going to be our input? What do you guys think? Is our input going to change? It's still going to be seconds? Okay. Juan is saying it's still going to be seconds. Max is saying it's still going to be seconds. Brian, do you agree with Juan and Max? Okay, Brian's in agreement. How about Eddie and Jesus and Jose? Do you guys agree we're still going to have our input be seconds and our output be temperature? What do you guys think? Here, let me put this into a poll. Okay, so yes or no, it's just simple yes or no. Input is seconds, output is temperature. That's going to stay consistent no matter what the values are. All right, Jose's on board. Eddie's on board, good. Okay, Juan already told me he was on board. Jesus, how about you? Okay, Jesus is on board too. Okay, we are all in agreement that nothing has changed as far as our inputs and our outputs here, right? We're still looking at an input of seconds and an output of temperature. So we can go ahead and fill in a couple of our blanks here. When the input here, when the input is something, the output is something. Okay, so our input is time or seconds. When the seconds is something, the temperature is something. Okay, so we've got that going. What do we know here? Oops. What do we know here? We can fill in one of these other blanks, but we only know one. Which one do we know? Okay, Juan's saying we know the temperature. Right, we know the temperature because we know the number in parentheses is our input, and what the rule gives us our output. Okay, so our temperature is going to be, Juan, what is our temperature? 35. Okay. So from this statement right here, f of t equals 35, we know that when the seconds is blank, we still don't know that one, the temperature is 35. Do we know from this statement what our time is? Do we know our time? Do we know our time? Juan says no. Anyone else agree? No, we don't know our time yet, do we? We just know that it is t. Okay. So we could put our variable in the statement. This is when our seconds is t, or after t seconds, the temperature is 35 degrees. Okay. What questions do you guys have? What felt pretty simple about that, and what felt a little bit tricky? Anybody have any thoughts? No, so far doing okay? Okay. Stop me if you guys have any questions. I want to make sure that we're all understanding and we're not getting lost. Okay, still the same situation. This is just a follow-on with some additional questions, but still the exact same situation here. Okay, so now that we know what is going on for f of t equals 35, where we know for some time the temperature is 35 degrees, we want to figure out what that value of t is. How could we figure out that value of t? What could we do to figure out that value of t? Anybody have ideas? Oh, Max, say that one more time. Yeah, that's good. Yep, it's the same picture at the top. It's just different questions. Yeah. All right, Brian, if we know that this function right here has an output of 35 degrees, what can we do to figure out what t is? What would you do, Brian? Gonna do what? Oh, okay. So Brian's saying we could plug in some numbers for t and see what came up with 35 degrees. We could try like 30 seconds and see if that gave us 35 degrees. Yeah, we could definitely do that. We could plug things in and we could test them out. We've done some of that where we do some estimation and see what works as a good answer. Yeah, we could definitely do that. Who else has other ideas?
Hey, Ms. Stefanacci, I just wanted to note that plugging in idea is a great one to try on like a multiple choice situation where you have a limited number of potential inputs. So particularly when you're doing like a map test or an SAT test, that strategy can really serve you well.
Yeah, that's a great point, Mr. Rose. Plugging that in and seeing what you get is a great a great thing that you can do that. Does anybody see an opportunity to turn this into an equation that we could solve for t? How could we turn this into an equation that we can solve for t? What do we know? So we know that we have a rule here. And we know what that rule is going to give us as an output. What is our output going to be? What's our output going to be here? 35. All right, Brian's saying our output is going to be 35. So we know that this rule is going to give us an output of 35 for some input. We're trying to find out the input. So we can use that to turn that into an equation. 22 plus 1.3t equals our output of 35. All right, you guys need to now pull all that good math 1 solving equations knowledge out, and let's see if we can solve this equation. I'm going to write it down here so I got a little bit more room. Okay, 22 plus 1.3t equals 35. What is my first step to figure out what t is here? What's my first step? Or what am I trying to do? What does it mean to solve this equation? Tell me what it means to solve this equation, and then you can go to the bathroom. What does it mean to solve an equation? What are we trying to get by itself? The what? Say that one more time. Well, I know 35. What am I trying to get by itself in order to solve that equation? What am I trying to find out? The t. Okay. Okay, so Brian said that what we're trying to do here is we're trying to solve for our variable. So we're trying to get our variable by itself. Okay. What would you guys, so what would our first step be? How do we get the variable by itself here? I can see that I've got my 1.3 is multiplied by it, and my 22 is added to it. All right, Juan's saying subtract 1.3. You're on the right track. We do want to subtract first, but not the 1.3. Max, what would you subtract first here? Okay, the 35. Oh, wait, Eddie, what are you saying? Okay, Eddie's saying subtract the 22. Okay, so we've got subtract 22, subtract 1.3, subtract 35. So we know we need to subtract a number. Which number is going to help us get something away from the t? If we subtract 35, that's going to move the 35 over to the same side as the t. If we can't subtract 1.3 because that's multiplied, so I'm going to go with Eddie's idea here. I'm going to subtract the 22. And remember, I have to subtract the 22 from both sides because what I do to one side, I have to do to the other side, so we stay balanced. Okay, 22 minus 22 is going to be 0. I don't have to worry about that anymore. I've got 1.3t equals, what's 35 minus 22? Who can do that real quick? 13. Okay, and now, Juan, you wanted to do something with the 1.3. What should we do with the 1.3? Divide it. Okay, let's divide by 1.3. All right, so 1.3 over 1.3, anything over itself is always going to be what? Oh, not 0. If I divide a pizza into 8 pieces and I eat all 8 of them, how many pizzas have I eaten? One. I've eaten a whole pizza. Yeah, so this is the parts. This is how many of the parts I have taken. So if I take all of the parts, I'm going to have 1 whole. Okay, anything over itself is always going to be 1. Okay, T equals, dividing by a decimal can be a little strange. So let's go ahead and do that on the calculator just to make sure that we are getting the right answer there. I'm going to pull up a calculator in a new tab. 13 divided by 1.3 is going to give me 10. Okay, we could have done that in our heads. We could have done that out on paper. If you want to use a calculator for those types of things, that's fine. All right, T equals 10. All right, so what? So, okay, so T equals 10. So what do we know? If we go back to the slide we were just looking at here, we had our sentence that said, when the seconds equals T, the temperature equals 35. So now we have figured out the T. We figured out that T is 10. So who can tell me what we know? What does it mean that T equals 10? What does this mean here, guys? Max, if we take the T out of here and put in the 10 instead, what would we say about that situation? So if we just read that sentence with a 10 in there instead of the T. Multiply it? Okay, we don't need to multiply it, we just need to say the sentence. Now we got the 10 seconds. Okay. All right. So Max was talking quietly, but what he said is that when time equals 10 seconds, or after 10 seconds, the temperature is going to be 35 degrees. So now we know how long it has taken for our temperature to get up to 35 degrees. Okay. You guys got that? Any questions? No questions? Okay, so we've been looking at some functions. We've been looking at the function notation and interpreting what that means. We've been writing sentences, we've been finding values, we've been saying, here's what's going on. We've been saying the words that describe what's going on. Now we're going to switch that around and we're going to do the opposite. Now we've got 2 sentences here. We have got A that says the temperature in the machine 30 seconds after it's turned on, and B, the time when the temperature inside the machine is 100 degrees Celsius. So we want to write 2 functions in function notation to describe each one of these situations. Okay, so remember, our input is time, which was seconds, and our output is temperature. Which one am I looking for in A here? Am I looking for the time or am I looking for the temperature? I'm looking for the temperature. Okay, I'm looking for temp. So I'm looking for the output. Okay, I know what the input is. How about in B? Am I looking for the temperature or am I looking for the time, or the input or the output? Okay, in B, I'm looking for the temperature or I'm looking for the time. Okay, I'm gonna give you guys 2 minutes and I want you to use, I'm gonna scroll up here. I want you to use our function here as a model to write 2 functions, one looking for the temperature here and one looking for the time in this situation. Okay, take 2 minutes and work on that. If you have questions, please let me know. All right, I see Juan getting going here in the PearDeck. I see Jesus doing a little bit here. Okay, I'm still waiting for some answers in the PearDeck from Jose and Eddie and Brian. All right, I see Jose getting going here. All right, still waiting for Eddie, waiting for some more answers. Jesus, I see you started the last question, but I'd like to see some answers on these right here. So we're trying to write a function for both A and B here. All right, take about 30 more seconds. Brian, we're working on A and B. Okay, so we're writing the function notation now. We're writing the function for A. So on A, we're trying to, and on B, so how would you write that in that function? So our input is T. So in the first one, we know that our input is time is 30 seconds. So we have a f of our input. We're working on A there, so the time is 30. Okay. Brian, you got it? All right. Okay, Brian, what did you do for the first one?
Oh no.
All right. Okay. Well, let's see. What do we know? What do we know how to do here? Okay, for A, we already have said that we know what our input is. Okay, we know that our input is 30 seconds. So we're trying to find our output. All right, I'm going to show a couple of responses here. All right, I'm going to show this one right here. So this one says that f of 30 equals, so f of 30 means when our time is 30, that equals our output. In this case, we could have, I mean, this person went above and beyond and said, oh, and here's what it actually means. So we've got 22 plus 1.3 times 30, because we know that's our t, and did the whole calculation and said, oh, that's going to be 61 degrees. Okay. In this case here, though, we know this input. We know our f of 30. Okay. In our second one here, we don't know the input. We know the output. So we know f of t equals this rule right here, and the output of that rule is going to give us 100. So f of t equals 100, and doing that calculation gives us 60 seconds. Okay, nice work on that one. All right, so we could say something here like, for A, we could say f of 30, because that's what we know. We know our time is 30, equals 22 plus 1.3 t, or times 30. Okay. For the second one down here, we don't know the time, so we know it's f of t, but we do know the output, and that is going to be 100 degrees. And then we could go ahead and plug that into our equation, and we could solve that. All right. What questions do you guys have on these? I see several people who put some other answers in here. Who has questions about this? Everybody's doing okay? Okay. Brian, does this make sense now? Here we know the 30 seconds, so we know the time. We can put the input in time. And we need to find the temperature. Here we know the temperature, so we can put down the temperature, but we need to find the time. All right, to wrap up this problem here, what are the two variables in the problem? I want everybody to write this in the PearDeck here. This is kind of wrapping up, making sure that we understand everything that was going on in this problem. So what are the two variables? What are the things that we were looking for, or that we knew, and which was the input and which was the output? Okay. And then second question, when you are given a value inside the parentheses, something like f of 8, does that tell you the input, or does that tell you the output? All right, take 2 minutes and respond to those two questions. Okay, and I would like to see a response from everybody here. I see Juan is getting started. I am waiting for responses from Brian and Max and Jesus and Eddie and Jose. All right, you guys are in the classroom. Answer these questions. Do this in the PearDeck so I can see. Okay, these two questions. What are the two variables we're thinking about here in this problem? Which is the input and which is the output? And when we see something like f of 8, when we see something inside the parentheses, does that tell us input or output? All right. Okay, good, good. Seeing some good answers here. Waiting for Brian and Eddie. Brian, type in the PearDeck. Type the whole answer. All right. That is not the whole answer. Write the whole answer. Come on, buddy. You got it. So what are the two things we were talking about in this one? Which were what? What was the situation? What was the two? But what is it? Like, what's the situation? Max, what were the two things we were talking about in this situation? What were the two things we were talking about? What were the in-person methods? You need to pay attention. Well, so this should give you an idea right here. Okay, so the two inputs. All right, I'm going to read some of these answers here. So the two variables, the two things we didn't know were the time and the temperature. Okay, time and temperature were the two things that we didn't know. The time was the input because we said the time was the thing that we could, that was just going to happen, right? Time is just going to happen. We're going to say for some amount of time, this is the temperature. Okay, so time was our input, temperature was the output. And it looks like most of you guys got the second part right. When you see a number in parentheses here, like f of 8, that means that that is our input. So in this case, this is our time. So this is the function at 8 seconds, or after 8 seconds have gone past, this is what's going on. Okay? If you have questions about that, please be sure that you come to study hall or office hours or send me a message so we can talk through this. This is, if you guys are not understanding that part right now, that's really, really important for you guys to understand as we move on and talk about functions. Okay, anybody have any last questions, comments, input they want to put forth? Okay, I'm looking a little bit at what we're going to finish up with here today. Okay. All right, so we can define functions by a rule that can be described in words and with expressions and equations. Okay, so we have a rule right here. So we can think of this as a little function machine. It's not as fancy as some of the other function, whoops, let me go to that one. It's not as fancy as some of the other function machines we've looked at, but we can see we've got an input, we've got a rule that does some work, and we've got an output. So how would we say this in words? Brian, tell me how you would say this in words. Just right here. What does that tell you to do? What's it tell you to do? Okay, and what do you do to that input and output? Okay, so you take an input, you cube it, and you get an output. Who can tell me what it means to cube something? Who knows what it means to cube something? Anybody remember? So when you think about a cube, I'm looking for something here that's a cube shape. I don't have anything here on my desk that's a cube shape. So if you think about a cube, what you have is like a three-dimensional square, right? So when you cube something, you take a square, like my little sticky note here, and I have squares that have a three-dimensional shape. So how I get that is I take a number, like say X, and I multiply it by itself 3 times. Cube means times 3. So I have the sides, the bottom, and the top. And I could write this as X cubed. Everybody remember that? Who can tell me what this little 3 number here is called? What's that called? What's that called, Max? Do you remember what we call that little number raised up here like that? It's with an E. It's gonna be times itself 3 times. Do you remember what that number, that little number raised up there is? You can go, it's called, okay, how about you? With that little 3 raised up there, what that number is called? An exponent, yeah, perfect. Okay, Brian's telling me that this 3 raised up there like that is an exponent. Okay, so this is our exponent. And that's when we multiply a number by itself multiple times. Okay, so we're going to take an input. So if our input was X, we're going to cube it. We're going to multiply it by itself 3 times, and we're going to get an output. So we could write that as an expression, something like this. Okay, let's go on. Same situation, let's answer a question about it. How do we find the output when we have an input? So if we had a certain input, how do we find that output? If our input is 1, what do we do? We said that this told us that we did like X times X times X equals X, whoops, not cube, X cubed. What if my number is 1? I do 1 times 1 times 1. What is 1 times 1 times 1? What is it, Max? 1, right? 1 times 1 is 1 times 1 is 1. How about 3? What would 3 times 3 times 3 be? Brian, what's 3 times 3? 9. Okay, what is 9 times 3? What's 9 times 3? You don't know that? Okay, who can tell me what 9 times 3 is? 27. Okay, 27. You did say 27? Okay, sorry. It's hard to hear with math on. Okay, so we can think about these things both as math and as words. Okay, how would we write? So we could write a function here. We could say take an input, so a function of X, we're going to take that input, take that X, cube it, and that gives us an output. Okay, oh, it said I named the function G. Sorry, my bad. It shouldn't be F. It said to name it G, so it should be G. G of X equals X to the 3rd power. Okay, all right, so let's look at let's go back to our learning goals today. So we wanted to understand rules of functions, both when they're written in function notation and what they meant, right? So we wanted to be able to describe that in writing. We wanted to be able to have a sentence that described a rule and function notation that described a rule. All right, in the PearDeck, I want you to tell me, how well did we do that? What do you still need to know to be able to say, I am an expert at going back and forth between function, rules, and sentences. Or, you know, like, yeah, I could take the quiz tomorrow. I want to hear your thoughts in the PearDeck. How did we do on this today? I got it. I need some extra work. I'm going to come into study hall because I don't understand. 4 days you're going to come into study hall, Brian? That's awesome. Okay, tell me if there's something you're not understanding. Tell me what it is that if you can describe it. If you can describe a question that you have, put a question in there. If you say, I was sleeping and on my phone and not paying attention, I'm going to come into study hall to get extra help. Yeah, that's cool too. Right? Max, how do you think that we did today? Do you feel like you can describe rules and function notation in sentences? Is there one part that you think is better than that you feel better with than the other? Okay, perfect. Understand where we get the inputs, but how we need to work on the outputs. That's great feedback, Max. I appreciate that. Okay. All right, good. I see lots of good feedback here. All right, I'm going to give you guys about 10 more seconds to finish that up. Then we are going to do the exit ticket. I'm going to put an exit ticket up here. And then I'm going to give you the rest of the time to work on the adventure assignment. That is due at the end of the day tomorrow. Okay. I saw somebody had a question on that. We do. Okay, so let me pull that one back up because there's a couple of, I want to make sure you guys understand that. Okay, so there's a couple different portions of this assignment. I'm going to pull this over here so you guys can see it. Okay. Okay, so here's the assignment. There's instructions, there's a rubric, there's the profile. Now, on the fact finding, you need to do all 4 questions. Fact finding. Do all 4 questions. Then you get down to that's this page and this page. Then after your decoder page, do either food or fun. So either do appetizer, entree, dessert, or see, try, visit. So do either food or fun. All right, hang on one sec, Max. Let me finish this, and then I wanted to talk to you about this anyway. And then the last one is the finale. Do 2 of 3. Okay, that's the minimum you have to do. Do all 4 of the fact finding, either the 3 food questions or the 3 fun questions, and then do 2 of the 3 finale or the word problems. If you do more than that, so if you did all of the food and all of the fun, I will take your best ones that you do. So if you miss one, but you get the rest right, I will ignore that one. So if you want to do all 3 of these on the finale, I will grade the best 3 that you do. Okay? All right. Okay, exit ticket. I'm going to put that up there. Jesus, I see you typing. Max, I know I need to catch up with you. I'm going to put up your exit ticket, though. That is this one right here. There are dots here. There's a red dot, an orange dot, a green dot, and a blue dot. Look at these rules and see if you can drag the dot to the correct description. Yes, Jesus, this is the assignment from yesterday. Okay, it's due tomorrow at the end of class. We've got time to work on it today. We're going to have time to work on it tomorrow as well, because we're not devoting a whole class time to it. So that's our asynchronous work for those 3 days. Okay. If you have other questions, please go ahead and put those into the chat. I will turn the PearDeck on to student paste. And you guys have got the rest of the time to work on the exit ticket and the adventure assignment. So there's a different assignment. So I was thinking about I thought that might work better for you the way you were. Okay, so it's the same type of work, it's just structured. So try that one, and if you have any questions on that. Okay.